All right, so we're going to take the derivative of f, and to do that, we're going to need our formula. So we're going to start with a limit, always as x approaches, or as h approaches 0. Then we're going to plug in x plus h wherever we see an x. So in for the x up top, we're going to put the x plus h, and in for the x in the bottom, we're also going to put an x plus h. So that's the first part of the definition of derivative. It's 3 parts. Sub in an x plus h wherever you see an x. Subtract the original function and take the whole thing that you just had and place it all over h. So that should be the setup for your problem if you're going to solve it successfully and get the derivative. So I look at this and I notice I have fractions within fractions. So I am going to multiply by the common denominator up top and in the bottom. I didn't love this, so personally I changed it before I found the common denominator and made this x plus h up top, but then I made the bottom x squared plus 2xh plus h squared minus 1. So I FOILed this here out, and then I subtracted the 1 from it. So then I was ready to multiply the top and bottom. As I walked around, I saw some of you did the top, but you forgot to put this stuff down in the bottom, and then you missed the whole denominator of your derivative. So the top and the bottom get multiplied by the common denominator, which is going to be x squared plus 2xh plus h squared minus 1 times x squared minus 1. And same in the bottom. So when I multiply up top, I got to, again, keep this limit going. And when you multiply up top, this times this, that crazy part cancels out, and you're left with the x plus h that's already there times this part here that wasn't in the bottom, the x squared minus 1. Minus. Now, I know that whatever comes next has to be in parentheses, so just as a helpful reminder to myself, I put a bracket here to say whatever I'm going to subtract, that negative has to get to everything after I'm all done. So I multiply this times this. The x squared minus 1's cancel out, and I'm left with x times this larger part here. X squared plus 2xh plus h squared minus 1. And then here's where the bottom part comes in. I'm not going to worry about it. I'm just going to write it all down there. So I've got h. I've got x squared plus 2xh plus h squared minus 1 and x squared minus 1. It looks like a lot, but in the end I know that that h is going to cancel out, and I'm going to end up plugging in a 0 for the rest of the h's. All right, so now I'm ready to start simplifying. I'm going to have to do some FOILing and some distributing. So I've got the limit as h approaches 0. If I FOIL this, I've got x cubed minus x plus hx squared minus h. Minus, I'm going to distribute this x into each one of these things. X cubed plus 2x squared h plus xh squared minus x. And notice I still have the brackets there because all I did was simplify within the brackets. That negative still has to get to everything. And in the bottom, I don't want to forget to write it. I'm just going to recopy it. All right, so now I'm ready to distribute this negative here. And hopefully some stuff will cancel out. Really, we want everything that doesn't have an h in it to cancel out. All the stuff with h's can stay because that's going to eventually cancel out for us. So let's see, I've got this negative x cubed canceling with this positive x cubed. I'm hoping this positive x cancels out, and it does with this negative x. And everything else that's left has an h in it, so I'm going to be able to factor out an h and cancel it. So I'm going to just kind of clean it up a little. Let's see what I have up top. This here does have a like term. The hx squared can combine with this negative 2xh squared for a total of just negative x squared h, or hx squared, it doesn't matter. I've got this minus h here, and I've got this negative xh squared. So that's everything up the top, and in the bottom, It's just all the stuff that we've been copying. So finally, I'm ready to factor out an h. Did I miss something out?
In the denominator.
Oh, thank you. All right. So there's our -1. Thank you. All right, so we're ready to factor out the h. And if we do that, we're left with a negative x squared minus 1. There's that placeholder that we need. Minus xh all over the denominator that, again, is just the one that we've been copying all along. Finally, our h's cancel out, and now that our h's cancel out, we're finally ready to plug in a 0 for h. So up top, I've got negative x squared minus 1 minus x times 0 over x squared plus 2 times 0 times h plus 0 squared minus 1 times x squared minus 1. So if I simplify this, I've got negative x squared minus just 1 up top. And in the bottom, all these zeros cancel out. I'm left with x squared minus 1 and then another x squared minus 1. So that's going to make our derivative of this function negative x squared minus 1 over x squared minus 1 squared. And as I indicated earlier, a lot of times they don't prefer to have that negative right there. So what you'll see, if you're like doing a multiple choice or if you're checking in the back of the book, they'll pull that negative out in front and take out the negative from the x squared, take out the negative from the 1. And that'll be the derivative of the function right there.